In this Harry Potter themed lab, we are going to be using the equivalent of a while loop to continuously ask the user for a specific number. And this number is going to have to be the same number as a random number that we will generate. If the number is too high, we're going to tell the user it's too high. And if it's too low, we're going to tell the user it's too low. And then we're going to continuously do this until they give the equivalent output to our random generated number. When we look at these first lines, they're all commented out. The pound or hashtag sign means the comment, and everything after it will be not run by our code. So we have the name of our lab, we have our name, and then we're going to have how we assemble it, which is AS-O, lab 4.0, and then lab 4.asm. And then after this, we're going to link it. We're going to link all of the .o files. So we need to do ld-o a.out lab 4.0 and then csc35.o. And after we do that, we can execute this with a ./a.out. After we have all of this, we can start writing our program. So our code is going to have two sections, a .data section and then a .text section. In the .data section, we're going to strictly have just labels, and the .text section is where we are actually going to be manipulating the user input in our code and where most of this is going to be focused on. But first we need our .data section, and we are going to preface this with a .intel underscore syntax, no prefix. And what this is doing is it's saying what format we're going to be using. And then we need to use .data, so we're going to be in our .data section. Later we need a .text, so we'll do .text and we'll just write below this later. In our .data section, we need to first print out our title part, and our title is going to be under this label. In our title, we're going to have .ascii and then greetings Ravenclaw student. Before you proceed, within 1 and 100 a number I need. So this is our prompt, and we could write this on separate lines, so giving it separate labels. However, we're just using a /n right here to separate the lines so we can have it all in one title. And then here we have two /n's for spacing and then a /0 to end this label. So the first thing that we're going to do in our .text section is actually finish this, and we need to write out .global underscore start to make our start global, and then we need to do underscore start and colon. And then after this, we're just going to print out title. To do this, we need to load the effective address of it into REX, and then we need to call print cstring to print it out. And this is going to give us our title as a string. After we do this, we need to do a calculation to get the random number. So we'll write create random number, and these labels right here are in comments, so they're never going to be called and they're never going to be executed. It's just for organizational purposes. And we need to now make our random number. So we're going to move 100 into REX like this. So now 100 is being stored in REX. After we do this, from the csc35.o library, we are going to call random, and what this does is it calls a random number between 0 and 99. It really calls from 0 to 100, however it does not touch 100. And this is similar to the randomization in Java. So after we have this, our project says that we want a number between 1 and 100. And this random call will only give us a number between 0 and 99. So we know we have to increment this random number by 1 basically. So what we can do is add to our REX 1, because after we do this part here, random is going to be REX. There's going to be some random number between 0 and 99 stored in REX. And all we're doing is just adding 1 to REX. Since REX is a temporary register, we are going to have to store this into another register. We can move REX into RBX by doing just this. So now RBX contains RAX. Now if we look back at the project, we know that we need to do a while loop. And this while loop is just going to repeatedly ask the user for an answer until they guess the correct answer. So what we can do is start making our while loop. this label is not going to be in comments because we're going to have to jump back to it. And we're going to be actually writing inside of our while loop for now. We are going to do load effective address, and what we need to load into here is another string that basically just says guess. And the reason why we're saying this is because we need the user to guess a number, so this is more of a prompt. We can go back up to the .data section and write our label as guess, and then do a .ASCII, and in here simply just write guess with a colon, a space, and then a /0 to end the line. We don't want to do /n because we want our user input to be on the same line. So we can go down here and load the guess into RAX, and after we load this in here, we're going to print, or we're going to call print cstring to print it out. And then after we do this, we need to create, and after we do this, we need to get the user input that is an integer. So we're just going to call a scan int. So we'll do call scan int, and this will grab and temporarily store the user's input. After we do this, we want to compare this to our random number, and then we will have different criterias for what it will do if it's the same, or if it's higher, or if it's lower than. So after our call scan int, we need to have a compare part. So we're going to compare our RAX, which is currently whatever our scanned int is, with our RBX, which is our random number up here. We are going to compare this, and then we are going to write statements for this. So we have the rest of our labels here. We have large in case the number that we input is larger than a randomly generated number. We have small in case the number we input is smaller than our randomly generated number. And then we have a correct label, just in case that the number we input matches our correct random number. Now, in our while loop, we're going to have to do jump statements that execute these. And we'll jump back into our while loop after we execute those statements so that we can keep this going until the user guesses the correct answer. So we have compare RAX to RBX, and we're going to say after this a jump statement. So we're going to use jump greater than in case our current RAX, which is the scanned integer, is greater than our RBX, which is the random number that we've stored. So if the number that we input is greater than a randomly generated number, we are going to jump to a label that we will make right now called high. We can go down here and make it. We can call this high. And in our high label, we are just going to print out the high part, or the greater part. So up here, it's called large. This is our label, where it says, alas, this is too large. So we're going to load the effective address of large into RAX. And after we do this, we are just going to use a call print cstring to print this out. And after we do this, we are going to have to jump back into our while loop because we are going to run this until we get the correct answer. So after we do this, if our input is too high, we're going to go into this label. Then we need to go back into our while loop to ask the user for another number. So below this print cstring, we are going to have to jump it back into our while loop unconditionally. So we're just going to do JMP, which stands for jump, and we'll do while like this. That way you can go back into our while loop. Now, if our number is too low, what we're going to do is a jump less than statement, and we will write this as low. We can go below our high and write low like this, and just do the load effective address into RAX. I think it's small. Yep, it's called small. So we're going to load small into RAX, and then we are going to call print cstring to print it out. And then after we do this, since it's not the correct answer, we're going to have to jump back into our while loop. So we'll do JMP while. And then if we get the correct answer, we can make a jump equals, which is a JE. And if we have a JE, we are just going to jump to the end because we need to break out of our while loop and then print out our congratulatory statement and then end the program. So we're going to say jump equals to end, and if we go down here, we can make our end label. In our end label, what we want to do is simply print out this correct part and then end the program. So we are going to load the effective address of correct into RAX, and then we are just going to call end program. So if we scroll back up, we can review everything. This is our .text section where we print out the title first. We create a random number right here, and then we have our while loop with statements that will execute based on the number that we input. And then we have our .data section, which has all of our prompts and all of our strings. Now, if we go back into our main part by doing Control X and then Y to save, pressing enter, we are going to be back here. So we need to first assemble our code. We're going to do as-o lab4.o and then lab4.asm. After we do this, we're going to press enter. We have no errors, so we can continue to link our .os. We'll do ld-o a.out and then lab4.o with csc35.o to link it to the professor's library. We'll press enter. We'll do ./a.out, and this will execute our program. And then it says, greetings Ravenclaw student, before you may proceed, within 1 and 100 a number I need. We're going to enter our guesses here. We'll start off with 10. This is too small, so we're going to have to guess another number. We'll guess 40. This is also too small, so we'll guess 60. Also too small, so we'll guess 80. Still too small, so we'll guess 90. And then this is too large, so we know it's between 80 and 90. So we'll just type 85. This is too small, so we'll guess another number, 87. Still too small, so it has to be either 88 or 89, which means it is 89. Unfortunately, it didn't print out the correct answer here. So if we go back into our code by using nano lab4.asm, we can see why that is. And that is because when I was in this end label, I called correct and I put it into RAX. However, I never called print cstring to print this out. So I need to use a call print cstring because the correct label, which is in our .data section right here, is loaded into our RAX. However, we need a call print cstring to print out whenever we have a label and we're using load effective address for it. We can exit, save this, clear this, and reassemble it. We can also relink it and then do a ./a.out to execute it. It says the same thing, and now we can guess again. I'll start with 50. This is too small, so we'll go to 80. Too large, so we'll guess 70. Too large, so we're guessing 60. Still too large, so it has to be between 50 and 60. I'll guess 55. Too small, so I'll guess 57. Still too small, so I'll guess 58. Still too small, so I will guess 59. And this is the answer. We have our code. I can try this again. If I clear it and then do ./a.out, now I'll enter my guess. 50, too large. 30, too large. 10, too small. And 20 was the correct answer. So we got two totally different random answers. That means our code works properly and we have this lab complete.